Okay, we shall not wait. We are going to start the lesson. Hi, Sherman. Okay, so you get your worksheets ready. We're going to go through the answers now. So let's look at question 1. What are the correct units for friction, for weight, and for pressure? Ezekiel, you want to start this? Ezekiel, what's your answer for this one? I couldn't hear you earlier.
Is it
Yeah, again?
A?
A. How do you get A?
I just like we learn in class, but I'm not sure.
You're not very sure, huh?
Sure.
Which is the one you're not sure?
Friction.
Friction. Okay. So friction, when we are studying friction, we are actually in the topic of forces, isn't it? Okay. And then friction, okay, is actually a result of frictional force. Agree?
Mm-hmm.
So whenever you see the word force, okay, the unit for forces will always be Newton. Weight is also a force, okay? And then pressure, yeah, Pascal. Okay, there's another way to actually represent pressure. Pressure equals to force over area, right? Okay, so Sherman, what is another unit for pressure?
Pressure?
Yes.
I don't know.
What is force? What's the unit for force?
I don't know.
Okay, unit for force is actually newtons. Okay, and then unit for area.
Unit for area?
Mm.
Yeah. Square meter.
Good. Okay, so another way of representing pressure will be Newton per meter squared. All right, because force is Newton. Can?
Ah.
Okay, so you all can write down on your notes or on your worksheet. Okay, so let's look at the next question. Which statement of pressure is not true? Okay, so this 20 Newton iron bar, 20 Newton stone, when they are resting on the ground, they both exert the same amount of pressure. Could that be true or false? Okay. Jocelyn says cannot see the screen properly. Can y'all see?
It's not full screen.
Okay, let's try again. Because for me, this one is actually full screen. Let's see. Thank you for telling me, Jocelyn. Let me see. I try once more. How about now?
Yeah.
Okay, it's okay now, huh? Thank you, Jocelyn, for telling me. Some functions are blocking. Okay. Can. Now, okay, where am I? Okay, a 20 Newton iron bar. Okay, and then a 20 Newton stone. Let's say the iron bar looks like this. Let me just try to draw something to show you. Okay, this is the iron bar. And then this is a piece of stone. Okay, do you think they both exert the same amount of pressure? Yes or no? Okay, cannot be, right? Sherman said no. Okay, why? Because the area of contact. Okay, remember pressure is always calculated using this formula. Since now they have the same force, 20 newtons, okay, we need to consider the area. What is the area here that is in contact with the ground? Right? And then what is the area here that's in contact with the ground? It depends on how this iron bar is being made into. Depends on the area that is touching the floor. All right, it depends on the area that's touching the floor. If this is a very big area in contact, then the 20 newtons will be divided, let's say, okay, in this case, let's say for the iron bar is divided by 10, okay, meters squared. All right. So the pressure will then be 2 Newton per meter square. But let's say this stone, okay, the area of contact is a lot smaller. So if I calculate 20 newtons by maybe 5 meters square, smaller area, right? So what is going to be the pressure? 20 divided by 5, this will be 4 Newton per meter square. So do you think it's the same amount of pressure? Of course not. It really depends on the contact area. So we will have to write this down. Depends on contact area. When I say contact area, then it's very clear. It is the area that's in contact with the ground. All right. So this is already our answer. Okay, let's just quickly go through B, C, and D. So the sharp edge of a knife exerts more pressure than the dull edge. Of course, again, it is about the contact area. Sharp edge of the knife, the contact area is very, very small. Okay, so it exerts more pressure. A lady wearing a pair of high heel shoes exerts more pressure on the floor than wearing a pair of sports shoes. So imagine your teacher, let's say you are sitting in the hall or the parade square, okay, during the assembly time. Then your teacher wearing a pair of high heel shoe walks down, okay, the row of students. Then your hand is sticking out. You rested your hand on the ground, okay? And then your teacher accidentally stepped on your hand. Painful or not? Tell me. Okay, then compare with, let's say, a male teacher wearing sports shoe, right? Accidentally step on your hand. Which is the one that will give you more pain? Jocelyn? Jocelyn, would you know? Okay, I repeat, let's say your teacher, a female teacher female teacher actually walked down the parade square. Okay, are y'all seated in rows in the parade square? Do y'all still gather in the parade square? When you go to school in the morning, do you all still actually gather? No, you go to the classroom, is it, directly? Or the hall? Oh, okay.
Classroom.
Classroom, okay. In the past, you all gather, primary school, you still gather in the hall, correct or not? In the morning when you go to school, correct. So if let's say your teacher is wearing a pair of high heel shoe, you know how high heel shoe look like now? Okay, it's one of the questions at the back of the worksheet. So the pair of high heel shoe might look like this, with very high, sharp heels at the back. Okay, at the back here, very sharp. So if your teacher accidentally, Jocelyn, step on your hand with this part of the shoe compared to sports shoes. Sports shoes is like, if I were to draw, not so nice on my drawing, but then the sports shoe, the base is actually very broad. Okay, you will out, right? Yeah, it's going to be very painful. Okay, and then the very broad section here of the shoe, if let's say a teacher wearing this pair of shoe accidentally stepped on your hand, it's less painful, isn't it? Correct? It's going to be less painful, correct? Which is why it explains very well a pair of high heel shoe, especially at the heel here, it will exert a lot more pressure on your hand. Okay? Now you understand or not? Why is it so painful? Because the pressure is so great. Okay, the pressure is so great. So it's going to cause a lot more pain. Understand this part? Okay. Skis with a larger surface area enables the skier to slide on the ground easily. Correct. This is true. Okay, because the contact surface is wider. Next one. Okay, Jocelyn, what is a parade square? I think y'all didn't have any chance to gather at the parade square. Okay, it is usually an open up space. Some schools is actually the car park area. You also have the school flag and the national flag there. It's in an open space. Okay, in an open space, not in the hall. Okay, it's on the first floor usually. Okay, that's called the parade square. It's in the open. But I think no chance for y'all to gather because of COVID in the last few years. Let's look at question 3. Yes, okay, Jocelyn, go. Which activity below does not rely on atmospheric pressure? Okay, breathing air into lungs. Okay, this involves atmospheric pressure. Opening a cabinet door. You're just opening a cabinet door. There's no need for any atmospheric pressure, right? Attaching a suction cup holder onto the wall. Okay, this one definitely yes. Sucking a liquid up a liquid straw. Okay, this one as well. Answer is actually B. So this one is for water pressure. Okay, if you have time, you can actually get your Coke bottle. The 1.5 liter Coke bottle will work very fine. Okay, if you have a plastic bottle like this, you can use maybe your scissors or the pen knife to make, okay, holes on 3 sections of this container. You can even make one more right at the top. Okay, tape this up first, tape all these holes up first, tape properly, add in water. All right, and then after that, after you fill up with water, right, you remove all the tapes. You look at how the water is flowing out. Okay, the most bottom one, okay, the pressure of the water that flows out is actually very great. So it's going to go further away. And then this one has got lesser pressure. Okay, so the water that flows out is going to look like this.